So we're getting close. This is the last section that we're going to be working through. We're just going to tackle the first half of it today. We'll see how it goes. If you guys are feeling like a double lesson today, we can maybe do that instead of having to do lesson and review on Monday. But let's see how this part goes. Our goal for today is to solve some equations that have parentheses in it. So we haven't seen too many equations that we've had to solve that also had parentheses in it. Now you guys have already dealt with how to get rid of those parentheses, right? That's that distribution thing that we did before. And you guys know how to get rid of parentheses when it looks like this also. You did some of those in your assignment. Some of us use a box. Some of you guys are doing sort of like a double distribution sort of thing. So we're just going to be using the same concepts to simplify these equations, and then we'll solve them. Before we get into it, let's make sure that we're good on the warm-up problems. I'm just going to work through these quickly. We'll see if our answers match. There are multiple ways to do each of these, so your solution might not look exactly like mine, but our answers should match. Did you guys get x equals 6 for part A? Wonderful. Part B, I've got some stuff that I can combine. 3x and 2x is 5x. 2 minus 25 is negative 23. I think I'm going to get rid of this 1x over here. Minus 9 on both sides. Negative 23 minus 9 is negative 32. Divide that by 4. 32 divided by 4 is 8, is it not? That would be negative 8. You good on that one? All right, this is kind of a new situation. I don't think we've seen any equations with x squareds in them before. Did you guys follow my advice over here and do what I said for that first step? So my hint here was, since you've got x squared on both sides, go ahead and do minus x squared on both sides. We're allowed to add or subtract anything we want as long as we do the same thing on both sides. That's going to cancel that, that's going to cancel that, and there's no more x squareds in this equation. After that, it's just negative 8x plus 12 equals negative 6x minus 4. And you all know how to solve that. You've solved lots of equations like that. If you haven't already, you can do that. I'm going to work through it quickly, and then I want to talk about the next one. So I'll get rid of the 8x there. Dun, dun, dun. I'm going too fast and making mistakes. I got 8 for this one. Is that what y'all were getting as well? Hooray! And then finally, part D. There are 2 solutions to this. There are 2 numbers that I can put in place of x that would make that work. What is one of those numbers? What can you take the absolute value of and get a positive 10? You could put a negative 10 in here, right? The absolute value of negative 10 is positive 10. What's the other number I can take an absolute value of and get a positive 10? 10. Yeah, the absolute value of a positive number is just the same number, right? So if I'm solving this, then my answer is x equals negative 10 and x equals 10. So we actually get 2 solutions for those. We're going to see some problems later on in the year where we have 2 solutions as well. All right, any questions on those warm-ups? Let's get into our new stuff then, guys. So again, our goal of today is just to solve equations, but now our equations have some parentheses in it. You've got a spot in your packets for extra notes. I think it's on the last page, close to the last page. And we put this in our chapter 1 packet and our chapter 2 packet also, but I want to go ahead and get this in here right now. There are 3 simple steps that you can look to do anytime you solve an equation. And if you remember to look for these 3 things first when you're solving an equation, it's going to make your life way, way easier. Okay, this is going to help you with anything in this class. It's also going to help you with linear equations that you deal with in geometry and algebra 2 and pre-calculus and calculus. These 3 things, if you'll remember, if you can just tattoo these inside of your brain and think about them every time you start an equation, make your life way simpler. So I'm going to label this simplify equations before solving. And I'm going to underline before because we want to do these things first. Before we start adding and subtracting and multiplying, dividing things on both sides, we want to do these 3 things first. All right, number 1 is parentheses. We want to deal with parentheses first. We want to get rid of them. So anytime we see an equation from here on out with parentheses, that is your first move. Make those parentheses go away. Find a way to simplify and get rid of those parentheses. Number 2 is like terms. If you got an x and you got a 3x and they're both on the same side of the equation, you want to put them together. You want to combine like terms. Before you start solving, and this is the one that a lot of times people will skip over, they'll start solving the equation before they combine like terms. They end up doing way more work than they need to. And then number 3 is variables on both sides. If you end up getting some x's on both sides of your equation, you know you can't solve, you can't get an x by itself if it's in 2 different places. So do what you need to do to get rid of variables on both sides. So before we start solving, we want to make sure that we do not have any more parentheses, that we don't have any more like terms that can be combined together, and that we do not have variables on both sides. Once we eliminate all of that stuff, you're going to get yourself down to a simple equation that you should be able to solve in 2 steps. Always do this stuff first, okay? So as we go through our examples today, I want you thinking about these 3 steps for every problem as we approach it. So here we go. We're going to do our first example here, and what is the first thing we're going to look for to eliminate? What was the first thing on the list we just wrote? Parentheses. I see parentheses on both sides, so we're going to deal with them. We're going to deal with them. So most of you were feeling pretty confident about doing this whole distribution thing, so go ahead and distribute. And when you do that, your parentheses are going to go away. 4 times 2x is 8x. 4 times negative 5 is negative 20. And then do the same thing over here with the negative 3. Negative 3 times 2 is negative 6. And negative 3 times negative 2x would be positive 6x. Check my signs there, please. All right, so we took care of parentheses. The next thing on our list was what? What was the second thing on our list of 3 things? Like terms. Now, do we have any like terms over here? Do you have any x's you can put together over there? Nope, I don't see any like terms. How about over there? Any like terms over there? Nope. All right, we're done with like terms. What's the third thing on our list? Variable on both sides. Do we have variables on both sides? Yep, we got to deal with that. Y'all want to get rid of the 8x or the 6x? There's no wrong answer here. The 6x? All right, I agree. Let's do minus 6x on both sides. That should make that go away. (8x minus 6x is 2x. All we got left over here is the negative 6. So doing one final check on that equation, don't have any more parentheses, I don't have any more like terms, and I don't have a variable on both sides. Now we're ready to solve. And since we took care of all that stuff first, that's a pretty easy equation, right? That's like a day one of Algebra 1 equation right there. So go ahead and solve that. You guys got this. You've solved a million equations that look like that. Get that x by itself. Make sure you're showing me your steps. All right, you guys are doing awesome. Let's keep it going. I'm going to let you guys start this one off on your own. You know what to look for first. First thing on our list is parentheses. I see some parentheses there. Can you guys please deal with those parentheses? When you finish that first step, go ahead and check the screen and make sure we're in agreement. Please don't just copy my work, though. I want you guys working this one out on your own. If you finish that first step, please check and see if you're in agreement with what I've got here. If so, continue on. If not, that would be a great time to ask a question. Is that what y'all ended up with? Did you remember to bring that 14 down? Remember, there's two other things on our list. The next thing would be combine like terms, and we do have some like terms to combine this time. Make sure you put those things together before you move on to the third simplifying item. All right, we took care of parentheses, we took care of like terms. Variables on both sides would be next. Do you see variables on both sides? Yep. If you haven't dealt with those, go ahead and deal with those. You can either get rid of the negative 2x or the positive 6x. It does not really matter. Your work might look different from mine from here, but that's okay. We should end up at the same answer. All right, how'd you guys do on number 2? See a couple people still working. Don't let me interrupt you. Keep going. Keep going. You are like one step away, I can see. Almost there. So are we feeling okay about this? Nothing really new today, right? You guys know how to distribute. You know how to solve equations. We're just kind of putting those two things together into one problem. All right, you want to see it get really complicated? Let's flip the page. I'll show you complicated. Oh my goodness. No, you guys are going to do so good at this. All right. Now, I'll warn you, these ones take a little bit more time. So in this case, I've got a situation where I have two binomials multiplying together. Now, there's a couple different ways to do this. Some of you like doing the double distribution method. I'm personally a big fan of the box. I'm going with the box. But if you're a double distribution enjoyer, go ahead and do it. I like the box. The reason I like the box is we're going to use this box to do something called factoring later on in the year. And those of you who are practicing the box at least every now and then, you're going to find it easier to do factoring when the time comes. Now, if you're not sure what I'm doing here, could be that you missed this lesson. This is the week before Thanksgiving. So either get my attention later on, or I recorded it, of course, so it should be on the playlist. If you want to check and see if you were here, the lesson was this one, was the 3.2.1 to 3.2.4 product in sum forms. We practiced doing the box, and some of you really latched onto that double distribution thing. So let me write down what I got here. I got 2x squared. These can combine together. That's 10x. And I got a plus 12. Equals, over here I'm just going to use distribution. 2x squared plus 2x times 6 is 12x. Right. A couple people still finishing up. Please check yours against mine. And then while you're waiting, see if you can remember those 3 things that we just wrote down on our notes a second ago. Can you remember all 3 of them? What are the 3 simplifying steps that we're going to do before we solve? One of them we've already done on this problem. First one was parentheses, and we already did that. What was the second one? Combine like terms. Now, do we have any like terms over here? We kind of did. Some of you had some like terms. You probably already combined them together. I hope that you did. Did you already combine the 6x and the 4x together? So we've already kind of done the combining like terms over here. There's no like terms to combine over there. So we've taken care of that. And then the next one was variables on both sides. Do we have variables on both sides? We got to deal with that. Okay? So now we got a lot of x's on both sides. But isn't this kind of convenient? 2x squared and 2x squared. What do you say we do minus 2x squared on both sides? And we'll just make both of those go away. That's pretty convenient, right? But even after we do that, we've still got x's on both sides. I got a 10x on one side and a 12x on the other side. We can't solve with x's on both sides. Which one would you like to get rid of, the 10x or the 12x? Can I get everybody's attention up here for a moment? I know some of you are working ahead, but I want to show you something kind of important, please. I think a lot of you chose to get rid of the 10x. How many chose to get rid of the 10x? Okay, can I get you to just pause and watch for a second? I'm going to get rid of the 12x, and I want to show you a very common mistake that my students make sometimes. So you don't need to change. If you already got rid of the 10x, just watch for a minute. Just set your pencils down and watch. If I decide to get rid of the 12x, I'm going to end up over here with a negative 2x, agreed, and a plus 12. Where does my equal sign go? This is a super important question. I hope that you won't miss this. I've been seeing a lot of people making this mistake on tests. Where does my equal sign go? Does it go in between those two things? No. Because the equal sign wasn't in between here to begin with, right? The equal sign needs to come right down where it was before, right? The whole idea, if your teacher made you draw that line back in middle school, is so that you would keep your equal sign lined up. The equal sign goes there, and then I need to put something over here in order to finish this problem. What is going to go over here? What's going to go over there? 12? No. Negative 12? No. Good guess. Everything went away on this side, right? What are we left with when everything is gone? Mathematically, when everything is gone, we have 0. There's a 0 over there. And now I can solve. So if you ever run into a situation where everything goes away on one side, you can't just go stick in the equal sign someplace else. You need to put that 0 down there and then finish solving. Okay, go ahead and finish solving. If you were doing this differently, if you got rid of the 10x instead, yours is going to look different, but we should still come up with the same answer. Now I see why you said negative 12, by the way. I would still say at the point we were at, we would not want to be writing that negative 12 over there, right? You did minus 12 on both sides too. Okay. Ooh, so you were doing things a little out of order. So that order that I gave you, those 3 steps that I gave you at the beginning, or a minute ago that we wrote down, you don't have to do them in that order, but usually if you do them in that order, you're going to have fewer steps. Usually, not always. So that's why I numbered them 1, 2, 3 instead of making them bullet points, because a lot of times you'll end up with fewer steps if you do them in that order. But there's no rule that says you have to do them in that order. All right, that was kind of a tricky problem, right? We got all kinds of x squareds and everything in there, and we dealt with it. You guys want to try one more? Yeah, we can't wait. Okay, let's do one more. Let's do one more. I'm going to have you guys work your way through this next one, this number 4. You're going to have to either do double distribution or the box thing twice. So I'm going to let you guys get yourself started. Please ask me some questions. I'm going to freeze my screen so that you can't see what's going on, and then we'll come back and check our answers in a moment. I've got my solution up there. I'll put solutions for the 2 at the bottom. If you would like to do some more practice down at the bottom, you can, but you don't have to at this point. You are going to see some more practice with this on your assignment as well. So I'll come around and pass out your assignment, and then I'll put those solutions for the last 2 up on the screen so those of you who are trying them can check your answers.